Good afternoon, everyone. Welcome to the extra session of this tutorial session on the course of Principles of Communication System. So today we will solve questions based on this course from week 1 to week 12, like whatever taught in the NPTEL lecture series. We will solve some of the questions that is related to GATE examination and related to this course. So any subset of all the set of the possible outcomes of a random experiment is termed as event. So option C is the correct answer for this question. And also we'll see some of the basic things. So like information source are random. So information bits which are transmitted. Let's suppose that transmitted 0 1 0 0 1 0. So the next bit is completely random. So information symbols are random in nature. Now let's suppose sample space. So sample space what it is? Let's suppose we have thrown two dice. So what will the sample space for this? Sample space will be like this: 1 1, 1 2, 1 3, 1 4, like this. Then again 2 1, 2 2, like this. It will go up to 6 comma 6. So the sample space is S here. And now what is S? Set of all possible outcomes of an experiment. So S is set of all possible outcomes of an experiment. Okay, so this is very simple. Like when we throw two dice, what happens? The what is the set of all possible outcomes? Like from 1 1 to 6 6. Like let's suppose one appears on one dice, then on another dice it can appear 2 1 2 3 4 5 6. So like that, there will be total 36 outcomes. Okay. Now let's suppose 1 comma 3 occurred. After throwing a dice, 1 comma 3 occurred. So in the first dice it occurred 1. In the second dice it occurred 3. Okay. So this is 1 comma 3. So this is just an event. So 1 comma 3 is just an event. What is event? Event is any subset of S. So for this question, the correct answer is event, like any subset of the set of all possible outcomes of a random experiment is termed as event. So now moving on to the next question. Before that, we will see the axioms of probability. So this question is very simple. So before that, we'll see the axioms of probability, some of the concepts which were taught in this week. So the probability measure of any set A satisfies three axioms. So axiom 1, the probability of an event A will be always greater than or equal to 0. Axiom 2, probability cannot be negative. Probability of sample space is equal to 1. Means probability of all the outcomes like in the sample space that will be equal to 1. Axiom 3, probability of A union B is equal to PA plus PB. This will satisfy only if A intersection B is equal to 0. This means this is A and this is B. Here we can see that A intersection B is equal to 0. So probability of A union B is equal to probability of A plus probability of B. Now let's suppose take a case like this where A, B is there. So this part is the A intersection B. So now probability of A union B is equal to probability of A plus probability of B. So now this part will come twice. So we have to subtract one time the probability of A intersection B. Okay. But if probability of A intersection B is equal to 0, if probability of A intersection B is equal to 0, then P of A union B is equal to P of A plus P of B. Okay. So this. So now we will move on to the conditional probability. So in this question, they are asking the conditional probability P of A such that B has occurred, the event B has occurred is. So conditional probability of A given B. So this can be also called as probability of A given B. So that is P of B has occurred, probability of A such that B has occurred is equal to probability of A intersection B divided by probability of B. Okay. So the correct answer is option number D. Okay. So also we can write it as probability of A such that B has occurred into probability of B that is equal to probability of A intersection B. So the correct answer for this question is option number D. Also, let's see here, probability of A intersection B can be written as probability of A such that B has occurred into probability of B. Similarly, probability of B such that A has occurred. This will be probability of B intersection A divided by probability of A. So it implies that probability of B such that A has occurred into probability of A that is equal to probability of B intersection A. So we can write from this equation 1 and 2 and both are equal probability of A intersection B that is also equal to probability of B intersection A. So we can write probability of event B such that A has occurred into probability of A that is equal to probability of A such that event B has occurred into probability of B. So from here we can write probability of event A such that B has occurred, that is equal to probability of B by A into probability of A divided by probability of B. So these are some of the formulas to be known in the probability. So we'll move on to the next question. The next question is, consider a uniform quantizer with 128 quantization levels and maximum mass amplitude is 1000. What is the quantization noise power? Now first we have to find the number of bits required to quantize the quantizer having 128 quantization level. So we know formula. So that is also known as resolution formula. Resolution R is equal to log 2 of quantization level. So here in this question, 128 quantization level is given. So when you put here 128, R is equal to log 128 base to the 2. So is imply that it will become 2 to the power of R is equal to 128. So what will be the value of R here? So is imply that R is equal to 7. So 7 bits are required for the 128 quantization level. Now it is given that maximum message amplitude is 1000. Maximum message amplitude is given as 1000. So from here, what we can do, so we have to find the quantization noise power. So quantization noise power can be given as sigma q of square. So from the uh, like we have studied the formula of quantization noise power as derived in the lecture is minus 10 log base 10 to the 3 plus 20 log 10 maximum message amplitude minus 6R. So this is the formula for the quantization noise power. So we have to substitute the value and we will get the answer. So just substitute. Now after substituting, what will be the answer here? So the quantization noise power is equal to minus 10 log 10, 3 will be minus 4.77. Okay. And 20 log 10 is log 10,000. So this will become 3 minus 6 of R. So R is here 7. Okay. R is the number of bits required. So that is equal to 7. So when we substitute, we will get minus 4.77 plus 20 into 3, 60 minus 42. This will be 18 minus 4.77. So that will be equal to 13.323 dB. And this formula is in dB. So we will write here dB. So the correct answer is 13.23 dB. So option A is the correct answer for this question. So coming to the question number 4, consider a binary symmetric channel with probability of A naught is equal to 0.6, probability of B1 such that A naught has occurred is equal to probability of B naught such that A1 has occurred is 0.25. AI and BI denotes the events corresponding to transmitter and received signal 0, 1 at the transmitter and receiver respectively. Then find probability of A naught such that B1 has occurred. So first try to understand what is binary symmetric channel. So A naught A1 here, B naught B1. So probability of B1 such that A naught has occurred is this, that is 0.25, and probability of A1 B naught such that A1 has occurred is also 0.25. Okay. So now what is the probability of A naught is given 0.6. So probability of A1, what it will be? It will be 1 minus probability of A naught. So this will be 0.4. Okay. Now probability of B naught such that A naught has occurred, that is equal to 1 minus probability of B1 such that A naught has occurred. So this probability is 0.75. Now the another one, probability of B1 such that A1 has occurred is equal to 1 minus probability of B1 such that, probability of A1 such that B naught has occurred. So this is 0.75 again. So these are the probabilities. Now we have to find probability of B naught such that A1 has occurred. So for this we can write probability of B1 such that A naught has occurred into probability of A naught. Sorry, in this question it is asking probability of A naught such that B1 has occurred. So probability of B1 that A naught has occurred into probability of A naught divided by probability of B1 such that A naught has occurred into probability of A naught plus probability of B1 such that A1 has occurred into probability of A1. So here we will add one extra page. So now we have all these probability values. So probability of B1 such that A0 has occurred is 0.25 and probability of A0 is 0.6 divided by 0.25 into 0.6 plus probability of B1 such that A1 has occurred is 0.75 into 0.4. So this value is 0.15 divided by 0.15 plus 0.3. So this will be 0.15 by 0.45. The final value is 1 by 3. So any option is there? 1 by 3? Yes. Option A is 1 by 3. So the a priori probability A naught such that B1 has occurred is 1 by 3. So done with question number 4. So now consider xt to be white Gaussian noise with zero mean and autocorrelation function for del tau. It is passed through LTI system whose impulse response ht is equal to sine 2 pi t. What is the power of the output random process yt? So when xt is passed through a LTI system, then output is yt. So the input power spectral density is x of f and output power density of sy of f. And the frequency response of ht is h of f. So that is the frequency response of LTI system. So here Syy of f, that is equal to xxx of f into magnitude of hf square. Okay. So now we'll solve this question based on this. And this is the output PST. Now the Fourier transform here ht is given as sine of 2 pi t divided by pi t. So the Fourier transform HF will be like this is equal to 2 of sinc of 2t. So for this, we know what will be the HF. So HF will be just the plot from -1 to 1. So this will be the frequency response of this HT. So here now H of F square, that will be again it will be 1 from minus F to F. So given input is white noise with autocorrelation here. Input is given white Gaussian noise with zero mean and autocorrelation of 4 del tau. So input is white noise with auto correlation 4 del tau. So which is implied the power spectral density, like that is XSXF is 4. Okay, for all f. So this is, let's suppose, input, that is 4 del of t. So the power spectral density will be 4. So now this value will be 4 into, and HF is 1, and for frequency minus 1 to 1. So this will be equal to 4. So the final value, we'll take the another page. So this is equal to, this is our HF mod of HF square, and XSXF is 4. So our power spectral density of output is 4 from the value of minus 1 to 1. So the correct answer of this question is 4. Sorry, it is asking what is the power of the output signal. So the power is area under the curve of the power spectral density curve. So this area is the power. So area is equal to 4 into 1 minus of minus 1. So this is equal to 4 into 2. So that is 8. So power is equal to 8. So the correct answer for this question is option number D. For a continuous random variable x, density function is given below. So the density function is given as this is minus 10, this is 20, and this value is k. And on y-axis, the density is represented as small fxx. Okay, so we have to find first k, second probability of minus x is greater than equal to minus 10 and less than equal to 10. Third part, we have to find probability of x greater than equal to 10. And fourth part is plot probability distribution function. Okay. Now, so the complete probability will be always 1. So the area under this curve will be 1. So the area is 30 into k is equal to 1. So the value of k is 1 by 30. Now probability such that mine x is greater than equal to minus 10 and less than equal to 10 is the area under this curve. So that is equal to 20 into k. So that is 20 by 30. So that is 2 by 3. Now third, probability of x greater than equal to 10 is 10k, because let's suppose this is the 10. So this value is 10 into k. So that is equal to 10 into 1 by 30. So this is equal to 1 by 3. Okay. So now the fourth part is the interesting one. We have to find probability distribution function that is equal to integration of probability density function. So probability density function is 1 by 30 from the value minus 10 to 20 dx. So this will be 1 by 30 into, sorry, minus 10 to x. It will start from minus 10 and it will go up to x. So 1 by 30 into x, and the value of x will be minus 10 to x. So this is equal to 1 by 30 x plus 10. And for what value of x? When x is greater than equal to minus 10 and less than equal to 20. So now let's plot this curve. So for x less than minus 10, this value is 0. For x is equal to minus 10, again this value is 0. And for x is equal to 0, the value will be 1 by 3. It will just increase. The slope is 1 by 30. It will just increase up to the value of 1 and it will become constant. So this value is 1 by 3 and this value is 1 and here it is 20. Okay, and this is x. So this is the probability distribution function. So now let's take one more example. A continuous random variable x is uniformly distributed in 0 to 10. Plot probability density function and probability distribution function. So for this, first we will plot the probability density function. So it is uniformly distributed in 0 to 10. So if it is uniformly distributed in 0 to 10, so it will be like this. Because the area under curve should be 1. So this will be 1 by 10 and this will be 0 and this will be 10. Okay. Now our probability distribution function is integration of probability density function. So this is equal to 0 to x 1 by 10 dx. So this will be 1 by 10 into x. So this is x by 10. So now the maximum value probability distribution function can take as 1, and this value will occur at 10. Okay. So this is the plot of probability density function and probability distribution function. So okay, we will solve one more question. The next question is very good question. It is a gate question. For a continuous random variable, density function is given by the probability density function. Small f(x) is equal to a e to the power of minus bx. Okay, and here small x is greater than equal to 0 and 0 otherwise. Or it can be also written as a e to the power of minus bx, and unit function you can write because unit function is 1 only for the value of x greater than equal to 0. Else it is 0. In both way we can write this density function. So find the relation between a and b. So when you plot this f(x), so this plot will come like this. Okay, so the total area will be always 1. So we can write integration of probability density function from minus infinite to infinite with respect to dx is equal to 1. So in this case, the value is from 0 to infinite. So this will be 0 to infinite a e to the power of minus bx dx. So this we can write as a by minus b e to the power of minus bx, and value of x is from 0 to infinite. So this is equal to minus a by b e to the power of minus b into infinite will be 0 minus e to the power of 0 is 1. Okay, and this value is equal to 1. So this imply that, or here you can write this is equal to a by b. So a by b is equal to 1. So it implies that a is equal to b. So understood how to solve such kind of question. For a continuous random variable x having density function shown below. The density function of x is given as minus 10 to 10 k f of xx. Okay, so find all possible statistical parameter. Whatever we have studied before, we have to find that. So the first is mean. Mean is equal to E of x. That is given as x of fxx dx from minus infinite to infinite. But here we know that area under the probability density function is equal to 1. So k into 20 is equal to 1. So value of k is equal to 1 by 20. So now we'll substitute, that is equal to, so fxx is 1 by 20. So 1 by 20 will come out and integration of x will be x square by 2. And this value will go from minus 10 to 10. So this is equal to 1 by 20. X square is 100 minus 100 by 2. So this is equal to 0. Okay. So the mean is 0. So also write a note point. If density function is symmetrical along x-axis, mean will be equal to symmetrical point. So here you can see the density function is symmetry to x-axis. The symmetrical point is 0. So the mean value will be 0. Okay. So now coming to the second part of this question, that is mean square value. So that is given as E of x square. So that is equal to x square fxx dx. So this will become 1 by 20 x cube by 3, 10 and minus 10. So when you substitute this value, you will get 1000 plus 1000 divided by 3. So 2000 by 20, how much? 100. So 100 by 3. Now the third parameter, that is variance. So that is sigma square, that is equal to m2 minus m1 square. So here m2 is 100 by 3. M1 is 0 square. So that is equal to 100 by 3. The fourth parameter is standard deviation. That is square root of sigma square. So that is equal to square root of 100 by 3. So it will be 10 by root 3. Now we will see Gaussian density function.